campers. Mr. O'Sullivan here. Hey, we're continuing our trek through piecewise defined graphs on the AP Calculus AP exam. And we're getting ready to take a look at the exam from 2006, question number 3, which was actually a calculator question. But I'll be darned if I can see where a calculator might be helpful with this question. So let's go ahead and see what we can do. The graph of function f shown above consists of 6 line segments. Let g be the function given by g at x equals the definite integral from 0 to x f at t dt. Well, as soon as I see that x as part of my definite integral there, I'm thinking I might have something to do with FTC part 2, which would tell me that g prime of x is going to be equal to, just take that x and put it into my integram, so it's going to be g prime of x is equal to f of x. Now this is very important because this kind of establishes the link between g and f, and g prime and f. So really, f of x is equal to g prime. So on my graph up here, I'm just going to add that and say the graph of f, which is equal to g prime. So that way, if I write that on my exam, I can use those two interchangeably. Okay, so let's see what we're asked to do. Part A, find g at 4, g prime at 4, and g double prime at 4. Part B says, does g have a relative minimum, relative maximum, or neither at x equal 1? And then justify your answer. And then part C, suppose that f is defined for all real numbers x and is periodic with a period length of 5. The graph above shows 2 periods of f. Given that g at 5 equals 2, find g at 10 and write an equation for the line tangent to the graph of g at x equals 108. Okay. Let's go ahead and jump into, let's look at part A. So part A asks us to do 3 things. Asks us to find the value of g at 4, g prime at 4, and g double prime at 4. All right. So part A, we're saying that if we get into that, and so if we're looking at g at 4, well, g at 4, I'm just going to use the definition for g at x here. So g at 4 is going to be equal to the definite integral from 0 to 4 f at t dt. Okay, well, to evaluate this, gotta look at the graph. So I'm interested in from 0 to 4. So I'm going from x equals 0 to x equals 4. So I'm going to be interested in this area, this triangle right here, and this area of this trapezoid right here. There's a reason why I want to do these in 2 separate colors, because the area of the red I'm going to treat as negative, a negative value, and the area of the blue I'm going to treat as a positive value. So let's do this little red triangle right here. That has a base of 1, has a height of 2, and so its area is going to be 1/2 the base times the height. So that's going to be equal to, and again, I want to treat this as negative because my function is below the x-axis. So it's negative 1/2 times 1 times 2. And I know I could simplify that, but I'm going to save myself some time and not worry about that. Plus the area of this trapezoid. Well, this looks like this has one base is 4, one base is 1, and then the height of my trapezoid is 2 units. So the area of my trapezoid is going to be the average of the 2 bases, 4 plus 1 divided by 2 times 2. Well, that's simple enough. That's going to be 5. So I have that. plus 5. Since I might need to come back and look at this, I am going to just simplify that. Just simple enough. That's just going to be -1 plus 5 is equal to 4. But again, I could have stopped as soon as I had a numeric answer. So that's my value of G at 4. Okay. Now I've got G prime at 4. So I found G at 4, and I want G prime at 4. G prime at 4 is equal to, well, now because I have this linkage that G prime of X is equal to F of X, I can say that G prime of 4 is equal to F at 4. Well, that's going to be pretty easy. I just need to go back up to the graph of F, and I just need to see when X is equal to 4, what's the value? Well, it looks like I have a Y value when X equals 4 on F of 0. So F at 4 is 0. G prime at 4 is 0. Okay. And now, next thing I want is G double prime at 4. Well, if G double prime at 4, if G prime at 4 is equal to F at 4, then G double prime at 4 is going to be equal to F prime at 4. Now I'm going to go back up to that same X value. But what I'm interested in is not the value, not the Y value of function F when X equals 4, but I'm looking at the slope of that line segment. So I'm really interested in this line right here, that line segment. And so I'm going to take the two endpoints of that line segment, 3, 2, and 5, -2. 3, 2, and 5, -2. And I'm just going to set them up in my slope formula. So that's just going to be equal to here a little bit. I'm just going to do that 2 minus -2 over 3 minus 5. And I'm going to stop there. That's just a numeric answer. That's the value of G double prime at 4. Okay. So there's part A. Did the 3 things there for part A. Part B now asks, does G have a relative minimum, a relative maximum, or neither at X equals 1? And then justify your answer. Okay. Well, I'm looking at G, and really all I have to look at is this equation for G at X. And then I also see this relationship here by the fundamental theorem of calculus part 2, that if this is G of X, then G prime of X is just equal to F of X. Well, that's going to be my path to let me determine if G has a relative min, a relative max, or neither at X equals 1, and that'll be my justification. So I'm looking at my function, and I'm looking specifically when X is equal to 1. So that's really what I'm focused on right there in my function. Well, I can see that G prime, also known as F, changes from, so I'm just going to write this, at X equal to 1, G prime, which equals F, changes from what? A negative value, from a negative to a positive. Therefore, G has a, and again, I kind of just make a sketch just to make sure I don't mess this up. If G prime is going from a negative value, I just draw a short line segment with a negative slope, and then it goes to a positive. And I just fill that in. Well, that's got to be a relative minimum. That's the only thing that'll fit in that. So therefore, G has a relative min at X equal to 1. Okay, now that is going to be my answer for part B. I'm going to say G has a relative min, it's okay to abbreviate, at x equal to 1 because, it's my symbol for because why? Because g prime, which is equal to f, changes from negative to positive at x equal to 1. Okay? Just double check. That's all I had to do. It's a relative minimum. And then justify your answer. Okay? That's my justification. The first part of that. Actually, the second part, g prime, which equals f, changes from negative to positive at x equals 1. Okay. All right. Picking up steam. Part C. Okay, now this is the Widowmaker. So part C says, suppose that f is defined for all real numbers x and is periodic with a period of length 5. Okay. The graph above shows 2 periods of f. Given that g at 5 equals 2, find g at 10 and write an equation for the line tangent to the graph of g at x equals 108. Okay. Let me clean this up just a little bit. Okay. So a couple things. I want to just make sure I'm understanding. They're telling me that f is periodic with a period of length 5. Well, I can look at this and I can see, okay, it's periodic, so it's like sine or cosine, or the trig functions that are periodic in nature. They're going to repeat every so often. And in this case, it's going to repeat every 5 on the x. So if we kind of look at this, we can kind of see, yeah, well, that makes total sense. You know, from negative 5 to 0, that's 5 units, and I get this kind of cut off kind of peak. And then again, it repeats. At 0, it starts again. I get the same thing, and it goes from 0 to 5, and again, 5x units every time. So we could think that, you know, this is just going to continue, and that we're going to have another one of these, you know, 5 units out here, where it's just going to do that same thing. Just sketch that, right? And it just keeps going on down the road. Okay, so that's what they're describing. And we're given 2 periods of f. So it says, given that g at 5 equals 2, find g at 10 and write an equation for the line tangent to the graph of g at x equals 108. Okay, so they're really asking us to do, in part C, they're asking us to do 2 things specifically. They want us to find g at 10, and then the second thing they want us to do is write an equation for the line tangent to the graph of g at x equals 108. Okay, well, that second thing, man, we've done that a bazillion times. Write an equation for a tangent line. We just have to figure out what the slope is and what our point of tangency is, and we're off to the races. Okay, well, let's find g at 10 first. So if we look at this, I'm going to move my work for A and B down below so I can kind of see my graph at the same time as my question. Okay, so okay, so g at 10, that's our first order of business. Okay, g at 10, well, I can go back to my definition, and I can see that 0 to x f at t. So I'm looking for a definite integral from 0 to 10 f at t dt. And they've given me that g at 5 equals 2. So actually, I can even kind of incorporate that and say, well, gee, if g at 5 is equal to 2, instead of having to go all the way back to 0, why don't I just start at 2? So I'm going to go, rather, that's driving the struggle bus here. My lower bound is actually going to be 5. Okay, because I'm given g at 5 is equal to 2. Okay, so what I'm going to do is I'm going to say, all right, if I think about this, FTC part 1 would say that g at 10 is minus g at 5. And then I'm given 2 is the value of that. So I'm going to add that to the other side of my equation, plus 2. And so I'm going to get 2 plus definite integral from 5 to 10 f at t dt is going to be my g at t value that I'm looking for. Okay, so I've got 2. I just have to evaluate this. Well, 5 to 10, because this is periodic, and this would, I guess if I could think of it this one, it'd be 6, 7, 8, 9. Well, there's 10 right there. Well, this is really going to be the same as, any one of these others in terms of the area. Right there. And then right here. Okay. Well, I know these are -1, -1, and this I found the blue trapezoid. That was 3 units by 1 unit by 2. So that's 1 plus 3 is 4. Average of those times 2. So that's going to be equal to 4 units. So that is going to be 4 plus -2, which is equal to 2. So really, for every 5 units I go over on the x, g increases by 2 units. Okay, so that is equal to 2, add 2 plus 2, so that equals 4, and that's my value for g at 10. Okay, so that's the first thing I found. Now the second part is write an equation for the line tangent to the graph of g at x equals 108. Okay, well, let's see. If I look at this, and if I'm writing the equation of a tangent line, my starting point is usually always y minus y1 is m times quantity x minus x1. And then I want to find out what m is, and then I want to find out what my point of tangency is. Okay, my point of tangency, I'm given x is 108, so I know that. Now I've got to figure out what's that corresponding y coordinate. Well, we're kind of given it as sort of a, it told us that g at 5 equals 2, g at 10 is equal to 4. And so it's almost kind of like if we think of this in maybe table fashion, might be easiest to see it that way. So that g at 5 is equal to 2, g at 10 was equal to 4, and then this is g at x. So if we think about this, we want to know specifically what 108 is, well, what we can do is we can say, all right, well, let's go to the nearest multiple of 5, which would be 105. And basically, how many multiples of 5 to get to 105? So if I take 105, divide by 5, I get 21. And then I know for each increase of 5 on the x, I increase 2 on the g of x. So I can say, all right, well, I know to get to g at 105, that's just going to be 21 times 2. That's going to be 42. But now I don't just go right to 105. I want to go to 108. So I have to kind of parse this up, this 5 units here. And to do that, I have to go back up to my function here. And what I want to do is, instead of stopping like right here to breakpoint, end of a period at like 105, I have to go 1, 2, 3 more units. 1, 2, 3 more units. And so really, I'm interested in, I already know that's -1. Now I need to know this area right here. Well, one way I can do this, maybe make it life easier, is that that triangle is going to offset those two. And really all I'm interested in is a 1/2 rectangle. And so that 2 units is going to be that portion for where I go from +2, 42 + 2 gets me to 44. So that is going to be my G at 108. Okay, so I went 21 full periods, if you will, and each period contributes 2 to the G at X. So that got me to a value of 42. And then I went this partial period, okay, and it wasn't linear. I had to go back up and look at my function, but I saw that, okay, the value here was, strangely enough, it was also 2, because really this cancels out. I had this 2, and then the remaining 2 units also would have canceled out here. So that's just kind of how that works out. So it was my value. Now that gives me my y value for my point of tangency. So I can at least do this. I can go y minus 44 is equal to m, I'll get to that in a second, x minus 108. Okay, now what's my value for my slope? Well, if I think of this, I'm coming up with, this really needs to be, if this is a equation for a tangent line that's tangent to function g, my slope needs to be g prime, right? G prime at what value? Well, this x value. So g prime at 108, well, again, g prime at 108 is like all the way, way far to the right, but again, because of the periodicity of my function, I can think of it like this. Remember, g prime at 108 is going to be equal to f at 108. And if f repeats every 5 units, f at 108 is going to also be equivalent to f at 3. Okay, what I'm doing is I'm kind of just pulling out multiples of 5. So I could do, again, that's my 105 there. And then it's going to be equivalent to sort of my remainder after I divide 108 by 5. So my remainder would be 3. So I'm really looking for f at 3. F at 3. Now I want the value, that's f. I just want the value when f is 3. That y value is 2. So that is the slope of my tangent line. So 2x minus 108 equals y minus 44. And that is the equation of my tangent line. All right, great. All right, guys, hope that helps. Thanks.